I'm from Toronto, Canada, and a lot of people, actually, like most of the people who are really good building scientists are Canadian. So maybe it's already in the blood, and that's what my father does. So
Oh,
like doubly in the blood in Canada, and then more directly through him. But growing up, I wasn't super thoughtful about what I would do as an adult.
mm,
Uh, I guess I sort of assumed I would just work in business, whatever that meant. I didn't really understand what that was. And then
yeah.
when like in college even, I'm sort of embarrassed that I was so casual, I guess, about it. But I didn't really think about it that much. And when I graduated, I worked for a little while in marketing and product development for a big grocery chain in Texas.
Mm,
And it was just a very different time. It was, the economy was really, really good. And it just seemed like the world was so big and that young people could get a chance to do a whole lot of different things in their lives. And
mm,
so it just felt low pressure in some ways. So I had a job offer in New York City. I had a job offer in Denver, I think, and in Toronto, where I'm from, and then one in Texas. And I took the one in Texas because I'd never been to Texas. Um, so I did that. That seemed like a good reason to make decisions, right? Like, I've never been there. Let's check it out.
yeah.
And I really liked it. That was the first time I was in Texas. I stayed only 2 years. I liked Texas a lot. I was in San Antonio, which is a city I love. I grew to really love it. But the job was not a good fit for me. I was terrible at it and I didn't like it. And so I was a little lost for a little while. I didn't know what to do. And I ended up going back to school for architecture. I sort of even stumbled into that. Had moved to Boston and was finding it hard to meet people there. So I signed up for a class at Boston Architectural College, the BAC,
Mm,
and it was really just to meet people. The classes were in the evenings because their sort of concept is to have students work full time while they're taking classes. So you could just take a class there, and that's what I did. I just took a class to meet people. I always kind of liked architecture, and I really, really liked it. And I had a friend who encouraged me at the time, like, if this is something that you like, if you like this industry, you should think about what you would need to do to grow in the industry. And it was really good advice because it wasn't so specific. It wasn't like you should decide right now what you want to do, but more like decide if you like this industry and what sort of credentials, if any, you might need to participate in the industry. And so I thought, well, I probably ought to have an architecture degree. And I guess I sort of early on had a sense I wouldn't all necessarily practice as a traditional design architect.
mm.
But anyway, and then I didn't. But that's how it started. Is I thought, I like this. I like the building industry. I like the design industry. I'd like to be in it. And so I enrolled as a full-time student the following opportunity I had the following semester, and became an architect.
Fascinating. What were the classes you initially took at BAC that hooked you? Were
I
they?
don't even remember. How funny is that? I don't even remember. I just liked it. So whatever it was,
That's
I
awesome.
liked it.
Yeah, yeah.
Um, I had a really good early first studio experience. Although it's funny the way different people remember things. So I'm still friends, as I'm sure many of your listeners are, and studio is an intense experience. So I'm
Mm.
still friends with my classmates from that, and they remember it a little differently than I did. Like, I remember it fondly, and they were like, "You liked that? That was terrible. That was the worst part of our schooling." Anyway, but I do. I really liked it, and it's sort of funny now. Our accountant has the same name as my first studio professor, which took some getting used to. So I'd see emails from him in my inbox, and like just my heart would stop for a second. Oh no, it's just my accountant. It's fine.
Yeah, it's a flashback to how many decades ago. Oh,
Oh
did I
my
miss an
gosh. And
assignment?
like all the all-nighters and the crazy, crazy questions you don't know the answer to. What does this building want to be?
Yeah, what is the essence of life via the building, the meaning of
Yes.
universe?
Yeah.
That's a good way to describe the studio, though. Going back, so it's interesting you said that building science and building scientists, I think was the term you used, is much more established in Canada. And I will say that all of my experiences in the United States, mostly professionally and then studying here and teaching here and all that kind of stuff, the term building scientist is not something I don't think I've ever really heard outside of you and the Building Science Fight Club. But it's just it's not described that way. We have practice courses about practice where you learn about envelopes and whatnot, but like the phrase building science I don't remember it being heavily used.
Yeah.
Is it more common in Canada? Is it a profession in Canada? I mean, it would seem to be.
Yeah, I mean, actually, it's not entirely carved out as a profession on its own. Like they have some building science programs, but typically building scientists are engineers, so their background is in engineering. But really, you learn this stuff through apprenticeship. So in that sense, it is similar to architecture. But most people who pursue it usually pursue it through engineering. I would say it's unusual to pursue it through architecture. And it goes by different names. So enclosure consultant or like enclosure specialist or envelope specialist is maybe a little bit more common, or forensic engineer, forensic architecture, depending on where you are, what's common in your area. But a lot of it it's a little bit similar to architecture in this sense also, in that people don't really know what it is, or they expect the profession to already be covered by whatever other professional is involved in the project. So they think doesn't your architect already know all this? Or doesn't your engineer already know all this? Or it's just that people haven't thought about how complex buildings actually are to begin with. It's not something that they think about. It's like fish don't know they're wet. We're in buildings all the time. We're not really thinking very much about building systems. They just work or don't work.
Yeah. Then people notice. So maybe on that note, so what is a building scientist? I know you've kind of talked about adjacent titles or different titles for it, but what does a building scientist do, generally speaking?
Well, I think there's actually some sort of maybe not controversy is too strong a word, but I don't think there's a super formal definition. But I describe what I do as specializing in the layers that separate the inside from the outside, and the different materials that make up those layers, what order we put them in, how they're installed, and then secondarily, how the enclosure, the layers that separate the inside from the outside, interact with the mechanical systems in our buildings. So mainly how we heat, cool, control humidity and ventilation. So that dual nature, how those two things connect to each other. That's how I would describe it to maybe other architects, to other people in the profession. I think, well, I don't know that I would describe it at all. Depends on how long I want to talk to them. I'll just say I'm an architect, or I teach. But sometimes they say I'm a forensic architect. So I specialize in what happens when things go wrong with buildings, and how to fix them, and understanding that buildings are, they're not just sculptures. Like we do things inside the buildings, and the things that we do in the buildings is valuable to us. So it's not enough to just identify what went wrong with a building, because it's like, okay, well, yeah, okay, we should have done that other thing that we didn't do. But now what? Now this hospital is open and we've got patients. What do we do? And coming up with a solution to how to fix a building with minimal disruption to whatever the building is being used for is a different kind of challenge, and takes a different kind of creativity. And then I'll tell people that on the front end, I help to avoid those types of problems. So that's usually how I describe it to lay people.
Fascinating. I mean, it makes sense, and it also reminds me that, talking about architecture school and practicing architecture, the things that, in my experience, you learn in architecture school tends to be more design oriented and less about systems. You do learn about systems and the layers you described, but
in a very broad and generic way.
And as a student who's 19 years old, it's kind of hard to comprehend or put them into practice, because even if you draw a wall section as a student, it doesn't have a lot of meaning to you because it's just foreign lines and you understand the basics principles, but you're not doing it yet. And when you get into practice, as you're working at an office, suddenly there's all this technical stuff and you're like, wait, what order do we put things in based on what climate? And some offices have a lot of expertise in that space because they've existed for a long time or whatever else. But there's also a lot of kind of inventing that takes place from project to project, even if the core principles are the same of how we insulate and keeping water out but letting air flow and whatever else. Still, that facade layer can be sometimes quite challenging to design because it's
or
different.
Design detail. If you're lucky enough not to repeat the same stuff over and over, like you work out a really nice detail, but you still have to meet those more like scientific criteria of how the building performs, and it's it's kind of a risk in some ways.
Yeah.
It is. That risk is exactly the right word for it. And I find that now that I'm teaching more, I find that speaking in terms of risk is really helpful for people to understand. And it also sort of helps them motivate them to want to understand this better, in that the less you know, the more conservative you have to be with your designs. The more you know the science and the better kind of context you have for understanding that risk, the more bold you can be with your designs. The more you can depart from what you did last time safely, assuming you actually care about your own professional reputation and your clients' safety and comfort and budget. But anyway, I think that ends up being. That's what I try to tell my students anyway, to make this a little bit more appealing to them, is if the better you understand this, the more bold you can be with your designs, the more creative you can be. It's not a hindrance to creativity. It's actually an aid to creativity if you understand your constraints better.
Yeah, that's well put. And there's definitely, I think for most architects, there's the side of the brain where when you're working through a detail, either on your own or with a consultant or someone in the office, it's kind of satisfying. It's like puzzle solving in a sense, but kind of a bit more complex because the image is not yet defined for you.
Right.
I was wondering, so what kind, so you teach, but you also practice as a building scientist and a consultant. Do you mostly work with larger offices, small offices? Is it a variety of projects and offices?
It's a variety, and it's changed a little bit too as other things in my life have changed as well. So right now I'm not doing any formal consulting. I just had a whole bunch of kids, and so I just just started working this past fall. I took a job as a professor at Virginia Tech, and so that's my entry back into the workforce. And I'm really just focusing on teaching for the time being. But prior to that, I was a consultant, and I ended up working with big firms and small firms, and mostly on residential projects when I was consulting by myself, as in working as a sole practitioner. Prior to that, it's sort of funny, it was completely different. It was mostly much bigger projects. Occasionally we'd have a house, but it would have to be a very, very large house. And the reason for that really is that bigger firms working on bigger projects, when they hire an enclosure consultant to do a peer review of their drawing, say, they typically want somebody that can work with them on all of their projects, because consistency is a risk reduction. Consistency in your approach to things is itself a risk reduction method. So there's actually a lot of right ways of doing things, but or the right way of approaching things. There's a bunch of right ways. There's a bunch of wrong ways too, obviously, but there's actually a lot of right ways as well. And it helps to, if you have a larger team, to have somebody who can work with you on all of your projects and give you a consistent approach, so that when you have staff that work on different kinds of projects, they can be hearing the same thing in the same way and approach things the same way. I just couldn't do that when I started my own firm and was working for myself. I couldn't handle a portfolio of 20 projects a year or something like that. So I ended up switching to work with smaller firms, doing primarily residential work. And that was a really fun transition for me, actually, because I think I find residential work more rewarding in a lot of ways and more challenging, because you have to, in residential design, you have to deal with everything. The architects do so much. They have to understand all of the systems. Whereas in commercial design, there's budget for and the expectation that you have different consultants handling different stuff. So you can sort of mentally kind of check out on stuff, be like, okay, I don't need to understand the elevator, right? There's consultants, there's people who design that stuff. I don't need to know about that. But you can't really do something similar in residential design. You have to understand and the architect has to understand everything. Now, I personally don't, like, I don't need to understand that stuff, but the same concept does apply. I need to understand a lot more about the integration between building systems and the enclosure than I do with commercial construction. There's just a stronger, or the lines dividing people's areas of responsibility are much more rigid in bigger jobs than smaller jobs. Even big residential projects. Yeah, it's you do have to understand a lot more, and so I find it more challenging and more fun.
So when you were doing consultant work on residential on your own, were you usually brought in before the building was built to make sure it was going to be built and detailed right, or were you also often brought in after the building had failed?
Both, but I preferred working on avoiding problems at the outset.
Sure.
I had done a lot of forensic work prior to that, and I was sort of a little bit burned out, a little tired of it. And a lot of it is sort of the same stuff. It's so
what's the biggest pitfalls, like the things that we all do wrong in our buildings that we should get right?
Well, what do you mean by we? I'll tell you, they're even boring to talk about. So most of it is leaks. So you could start if you were working. So I started working for a big consulting firm, and like 80% of the problems were leaks. So it was doing water testing to isolate the pathway that the water was taking to get into the building, and looking at how it was built and what that pathway could be. I would be pretty happy to never do a water test again in my entire life. I did enough water tests. I mean, sometimes they were fun. I did one at or just interesting. Like I did one at LAX, actually, here in Los Angeles. So their air traffic control tower was leaking. And so that was there were interesting constraints with that. And also LAX is just a cool airport. The design is cool. So there was some interesting construction elements at play. And practically speaking, like getting a boom lift on at an airport that's working, like where planes are taking off and landing. Yeah. That was a fun kind of job. But often they were just something is leaking, like go find it. So anyway, it was a little bit less interesting. The preventing problems was, I found it, I was ready to focus on that, I guess. We just go through different stages of being interested in different things. So I kind of was drawn a little bit more to that. The forensic, I shouldn't make it sound that bad. There were other interesting problems. There was, I worked at an opera house once that was just unpredictably smelling like sewage, and performers were refusing to perform there because that was not present.
Okay, it was that bad. Yeah,
it was real bad. And that one was a really, really interesting investigation. I was working with two colleagues that I find really fun and that I respect a lot and that know a lot of stuff. And I learned a lot through the investigation. Odor investigations are really hard. You have to end up kind of pressurizing the building in different ways and playing with different pressure relationships to try to recreate the condition, which is the smell. So you walk around trying to, does it smell bad yet to you yet? You know? And so it was sort of a fun, that was a fun investigation. It was also one where I really was worried that we wouldn't figure it out. I always do that. Anytime I get a job for a failure investigation, I'm like, what if I don't solve it? Like, what if, they've paid me all this money, and you spend money to go out and investigate it either way. but like, what if I don't figure it out? And that was the one that I think came closest to what if we don't get this? But we figured it out. We were on site 3 days, and we figured out the afternoon of the third day.
So what was causing the leak?
Oh my gosh. So it was a really interesting building. We had to rule a lot of stuff out first. It was in, I guess I can say where it was. It was written about in the paper, so I guess I could say about it. Anyway, it was in Aspen, Colorado, and Aspen has a lot of abandoned silver mines under the city. Yeah. So we thought, our hypothesis was that this opera house was somehow, it had like a substantial below grade portion, and that it was somehow connected to some sort of mine shaft or something, and it was pulling sewer gases from somewhere. That was our hypothesis going in. So we had to rule all of that out, which was very time consuming, and it turned out not to be that. It was such a simple problem. It was the air intake for one of their air handlers was located on a roof, and it was not like geographically close to a plumbing vent stack, but when the wind blew a certain way off of the mountains, it would blow the vent stack odors right into the air intake. And we figured it out, by the way, with this great guy, fantastic colleague who we brought in on the job. He was outside of our firm, but we brought him in to help because he happened to live in Crested Butte. And he came in and he illustrated it by borrowing a cigarette from the building engineer, lighting the cigarette and holding it. He was very tall, so he held it right at where the top of the vent stack was. And like 30 seconds later, we smelled it inside the control room of the audio. I don't know how to define these spaces, the audio visual control room of the opera house or whatever, the place where they control the sound and the lights. And I mean, it was like instantaneous. It was really, really incredible. Also sort of an interesting reminder at how kind of pungent cigarette smoke is. Like, a little bit of it. Like
it's gross.
Yeah.
It's gross.
Anyway, so it was sort of funny that we had all of this equipment with us to pressurize and isolate and measure pressure relationships in buildings. It was a very complicated investigation, and we ended up having to essentially, we demonstrated this to our client with a lit cigarette. Like that was it. And anyway, after 3 days of work, and it was just a lit cigarette and a plumbing vent stack. Go figure.
If it works, it works. But that also is a reminder that the complexity of buildings, especially, I mean, houses can be very complex for sure, but larger structures, there's just like 100 or 1,000 things to try and coordinate. And sometimes things don't end up working out great in the end. And it's like, who could have possibly predicted this thing causing an inconvenience? It'd be impossible to know. It's impossible to plan for some things that don't go, totally correct.
So speaking of that, you want to know what the problem was at the air traffic control tower at LAX?
Yeah.
I'm separated by enough time, I think I feel okay sharing it, but it was crazy. Speaking of complexity. So what had happened was they had this leak in the control tower, and the leak occurred to them, or they noticed it after they had re-roofed the building. And so they assumed that the roof, the roofers had done something wrong when they replaced the roof. And so they struggled with, they had the roofers come out and look at it. Nothing was wrong. They assumed it was the roof and couldn't really figure it out. And the roof was like this, in fairness, it was a pretty complicated, kind of undulating roof, and had curves and stuff to it. So it was a complicated roof. But that's what they assumed the problem was. Oh, and I forgot this part, they had mirror leaks at 2 corners of the building that were architecturally symmetrical, right? So whatever was going on, when I heard that, I was like, okay, well, it's very likely then that whatever architecturally happened on one side was repeated on the other side, which made me kind of think it wasn't the roof, because that would be a weird thing to sort of have two holes in your roof at the same spot. That would be weird. Anyway, what ended up happening was we went to all this trouble to get boom lifts up to do a water test at the location that was leaking, which was up high near the wall to roof interface. And I ended up going up there, and before I even turned on the water, like, I looked at it and there was just a hole in the building. So like, just open, like I could put my hand through it. Like if you were a bird, you could fly in there. I'm surprised birds didn't fly in there, actually. And it was where glazing on, it was at a corner of the building. So it was where glazing on one part of the facade met metal panels on the adjacent elevation. So they met at a corner, and nobody had coordinated that connection really well. So it's open, like actually open. And when they re-roofed, they had this gutter on the roof that ended up directing water right at, like, into the hole.
Gosh.
Oh, I forgot to mention, I guess the building was much older. So this had been in there. Like, they asked, well, how long has it been like this? I was like, I guess since the beginning. Like, so it's been like this for 30 years. And it wasn't until they re-roofed that this happened. And two other maybe interesting things about this project. One was that I bid it as a fixed fee project. So, which is a little bit risky, but I hate billing hourly. I'm sure it's like, to me, that is like the worst part of architecture, is billing hourly and doing a timesheet. I just, I loathe it. And so we did this one as a fixed fee job, where it's also very risky, right? You sometimes get completely burned by this. Well, we figured out what the problem was. I'd been on site 20 minutes. And hadn't done a single water test. And also it was kind of dangerous. Like, we're at an airport. This was the boom lift was high. This would have been like, I don't know, like 40 feet up. Like, it was, this was not, anyway, this wasn't like somebody's home in the suburbs or something.
Right.
And so I had to kind of ask myself, do I want to continue to do a test, even though I'm pretty sure I know what this is, to sort of make it look more sciencey? Or do I want to get down and tell them, you have a hole in your building, like, fix the hole and we'll be okay? Yeah. And I ended up deciding I'm not gonna do the show. I'm gonna just tell them what the issue is. Like, I'm pretty confident that if I spray water at this hole, water will get in the building, and that I'm pretty sure I don't need a test to validate that. But I did go to the other side and look at the other side, and there was a hole on the other side too. So it was the same, hadn't coordinated, and that's why they had these dual leaks. I had brought, to do this investigation, I needed another person, and everybody at the firm who normally works on this was not available to do it at the time that we needed to get it done. And so I asked one of my classmates from my very first studio, or actually, she probably wasn't my first studio, but that I went to architecture school with. And she has her own firm with her wife, but they had done some graphic design work for our company. So she was, like, technically an employee, I guess, but not, like, that wasn't her job to do these investigations. She'd never done one before, but I just needed another person, and she's smart. And so she came out to help me. So she's never done this before. And so she was a little, I don't know, but for her first investigation is a water leakage investigation at an air traffic control tower at LAX. And we figure out what's going on in 20 minutes. And also, people assumed that we were going to be there all day. And we're at an airport, our cell phones don't really work, like at the air traffic, and they tell you to turn it off at the air traffic control portion, all this stuff. Anyway, so we wrapped up, put the boom lift down, and took our hoses and went to the beach. And nice. So I had a nice fun time with an old friend at the beach, and we had margaritas, and then she took the red eye back home. She was based in Boston. I was based in Dallas at the time, and
That's
Anyway.
funny.
Oh, and then the second part, I bid it as a fixed fee project, and the FAA afterwards audited that job and said, because the report that I did was like 3 pages, it was so short. And they said, well, we don't think that this report is worth what we paid you. And so we're not going to pay you for it. So
What?
we think it's worth less. So they reduced the fee. And
Well, they should have got up on the roof and see the hole before
know.
hiring you, and that's that.
That's
I mean,
nonsense. I
yeah.
mean, you're paid to do
You're
a
not paid
gig.
per like how big of the issue you find, like
Yeah.
you know.
right? Or how long the report is. My
Yeah.
first answer
Yeah.
was like, do you want me to make the
should
font
have-
bigger for you? Like,
You should
I
have.
can
You
make
should
it
have.
more pages.
Yeah,
You
change
should
the
have written
margins.
something about your beach excursion or something just to make it longer. You know?
Those margaritas were expensive, okay?
Yeah, that's right. That's right. So
So
that was one, like you usually, like not usually, but like you usually don't come out ahead on fixed fee projects. You
Yeah.
you make you come out maybe modestly ahead, or it's, you know, like pretty close to what you estimated, or you lose money. And this one was one where we came out ahead because it was so simple. But the client just didn't pay. So,
So, yeah, they should have paid. So I guess the lesson is that if you have a point of failure in your building and it's water intrusion, I guess the first thing is go look to see if there's a hole in the side of the building.
in fairness to them, it was very hard to see. Like you had to really get up to it.
Yeah.
But yeah, look, and that's actually, I tell my students this too. Like they say, like, doing these investigations seems really mysterious to them. And I tell them that really the most important tool you have are your eyes. Like go and look. And sometimes looking means making an opening in the building so that you can see how something was put together. And like that is just the biggest resource, is look to see how it was put together, and then put a hose on it and see what happens, and play around with water to like rule stuff out. You know, like you start low to high, you mask off different areas, and spray adjacent construction and try to replicate the leak. But the biggest thing that you're doing is you're just looking. And it's amazing how many clients don't do that first. I think they're sort of afraid of their own building. But it's amazing if you just like, they also don't like to violate the building. Somehow they feel like it's a violation, where put a hole in the drywall, take a look. Like,
probing and whatnot. Yeah,
they don't want to do it, but
Yeah.
once you do, or once if I tell them that they have to, then they do it, and then they're like, oh, okay, this is so much better. Yes, it's much looking is much better than guessing.
Yeah.
As it turns out.
I think going back to your earlier point about commercial versus residential is something that I've seen as well, and it's a big difference in the two spaces. Part of my career was working at larger offices, and we did big buildings, and in those buildings you have a whole team of people, and they're all experts, and it's actually really nice because you can pick up a phone and call someone and say like, hey, you're the expert of the elevator or the facade consultant or whatever, and figure it out. The residential space is, for the most part, exactly as you described. It's kind of the Wild West, and it's hard to find the right experts. I mean, so in our case, this is kind of a tangent, but in our case, it's having projects that are large enough to where it makes sense to have a team of experts, not even a full team like you would have in a commercial structure, but just a few more people of consultants, and then finding the good ones, which tends to be sometimes harder to do in residential, I feel like, because it's not as systematized.
And then there's the whole contractor aspect of residential too.
Yeah.
Like you could have really great detail and have it all worked out, but if the guy who's building it is drilling through the waterproofing membrane when you install a rain screen, you're like, look, man, like you completely missed the point.
Or other things that we've seen that it's just
Yeah.
But getting to the big topic, which is the opposite of water,
I was going to say,
is, in LA, there are these horrendous fires that just kind of swept across the city. And we've been talking to a lot of folks, locally and not locally, about what can be done in terms of rebuilding. And that spans a lot of different topics. But one of them, of course, is when we hopefully go to rebuild or build new houses, if folks can make sure that they are more fire resilient than they were. And a lot of the houses, some of the houses were newer in the last maybe 15, 10 years. And a lot of the houses were significantly older from the 80s, 70s, 60s, 50s, whatever. And I guess as an introduction to that topic is what are, in your mind, some of the key things that clients, builders, architects, we should all be doing toward this effort to create houses that are more resilient than the ones that were quickly burned up?
Yeah, I mean, some of it is stuff that we can, I think it's important to, let me back up for a sec. I think it's important to acknowledge that not all of this is architectural. Like, so we're trying to use architecture to help solve a problem that isn't primarily, I don't even think, architectural. So from a certain perspective, like if you've got a massive fire, there's going to be some things that you could do to perhaps reduce your risk, but if it's coming, it's coming. In the same way, like sort of, I think about it a little bit with like tornado resistance. I mean, if there's a tornado and you're in the path, you're in the path. Like you have a basement, but there's some things that you can do to reduce the spread, but I'm speaking not as an expert in fire, like in wildfires or anything like that. So from my understanding, there were certain things that were just truly, that made this fire a little bit different and in some ways kind of unavoidable. That said, not all fires are like that. And there's all kinds of stuff that we can do architecturally to reduce risk, from stuff that's sort of intuitive that I think your listeners certainly already know about, people already know about, like how you landscape your property, for instance, will have an impact on how easy fires are to spread. But I think one of the things that's perhaps less well understood is how we construct our roofs in particular. And is that what I want to start off talking about?
I know. I realized as I was talking, introducing this subject, I'm like, there's like 6 different ways we could go right now.
Yeah, there's a bunch of different ways. I think before I say what I want to say about roofs, I think that there's one big misconception, and that is that in order to fight fires or make our homes and buildings more resilient to fires, we can't build with materials that can burn. That is not true. We're actually quite good at using materials that can burn by themselves in ways that are resistant to these types of events. So it's not true that in order to make a fire resistant home, we have to build out of like only concrete. Or I saw some sort of early coverage of this in the press that was talking about like not using wood anymore. You can build a wood framed house that is pretty resistant to fire, and certainly a lot safer than a lot of buildings that like are existing buildings. Like we know how to do some things now. I think the roof component is something that I happen to know a lot about, and I recognize it as very significant, but it's not the only factor. So the broad strokes of this are that roofs are typically, in residential roofs, are typically vented. And what that means is that we allow air to come in at the soffits and to be released at the ridge. So if you think of a house the way a child would draw it, just like a triangle,
nice.
It comes in at the sort of the bottom edges of the triangle, collects moisture on the underside of the roof, and then escapes at the apex of the triangle through a vent, through openings that we provide at the ridge, at the apex. And
so for folks who are let's assume the audience doesn't know anything about building science, why would we need to vent that space at all?
So what this is a moisture management strategy. So attics will get moist. And so if we think of the house, we'll take another quick step back. And actually, before I get into this, I will say that where we're headed with this, if you're a listener that understands this already, stay, because there's something that I bet you don't know yet about this new way that we can do stuff that's specific to California. California in particular is poised to be able to make some really, I think, great changes that can't be made other places. California's climate is uniquely suited to a new type of moisture management strategy in roofs that is much more fire resistant and not expensive at all, actually, not more expensive at all. But anyway, so that's where we're going to end up.
Oh,
but
you've teased us. That's good job. Yeah.
But to start, that previously was not permitted, by the way. The code did not permit this before because we didn't know about it before. We had to figure this out. So anyway, what we do is we vent our roofs to remove moisture from our attics. So typically, if you think of a house the way a child would draw it, like a square with a triangle on top, we intuitively know that we have to deal with moisture that comes from the outside of our buildings, typically in the form of rain or groundwater. What we think less about is about the moisture that's generated inside our house from cooking, cleaning, breathing, working out, doing whatever we do inside our houses. We actually emit a fair amount of moisture, and that moisture ends up escaping into our attic through imperfections or I shouldn't say imperfections because that suggests it's an installation defect, but through discontinuities in those layers that separate the inside from the outside. And moisture-laden air, it's usually air, gets through these little imperfections. So like the lights in your ceiling, right? Those are holes. And they're pathways for warm moisture-laden interior air to get into the attic. And in the wintertime, even in California, even in mild climates, they still have winters, and there will be cold surfaces in the roof, and particularly the roof structure and the underside of the triangle part of the roof that we make out of wood. And those surfaces will be cold, and we'll get condensation on those surfaces from this interior moisture. Just like you get condensation on a cold can of soda on a hot day, you'll get that on cold surfaces in your roof, even in mild climates. So this is typically a wintertime issue. And so we vent roofs to remove that moisture. It is a strategy that is really inexpensive, and it works in every climate. It is unbelievably effective at dealing with moisture. And this is why it's so popular. So not expensive, works in every climate. You can see why it's really popular. The downside to this is obvious based on how we started this conversation, but that if we open up our roofs, the underside of our roofs here, our attics, to air, to flush out that moisture, we're also opening them up or permitting the entry of flying like embers. To me, this was sort of an academic discussion prior to really seeing the coverage of the Los Angeles fires. And I think you probably saw it also, but like, I don't know. I thought of embers as like occasionally sparks off of a campfire or something. I didn't understand how insane it is when there's a real wildfire going on. Like the embers are like fireflies. They're everywhere.
Yeah, it's a cloud of embers.
It's like rain.
Yeah.
Rain of embers.
Yes. Anyway, that was something that I found really arresting and very sobering about the fires. But those can get sucked into a roof and into an attic and ignite the wood, the insulation, all the stuff that's in there, and then you lose your house. Like it's kind of over once the fire starts in your attic. It's over.
And basically, I mean, with the ventilation in the soffit and the ridge of the roof, you're kind of creating a fireplace in some ways, right? Like you're creating an air chamber, so you have that spark in there, and it functions the same, except it's not made of masonry, so it's just gonna, go up in flames.
Exactly. We don't have to vent roofs, though. It's just the easiest, least expensive way of dealing with that moisture. So the alternative, and I should have added here that think again of the house with the square and the triangle, the way a child would draw it. We insulate in these vented roof conditions or vented attics. We insulate on the flat. So homeowners will go up into their attics that are typically unconditioned. So it's storage space. There'll be a little attic hatch, and you climb up there, and you can see the insulation is like loose fill insulation or batt insulation, and it's just loose laid on top of the ceiling. So it's on the flat part of the square. We don't have to do that. We could not vent our roofs and condition our roofs and our attics, and we could treat that triangle space as part of the enclosure. So instead of insulating on the flat, we could insulate on the pitch and not vent our roofs. But if we do that, we still have moisture that escapes, and we still have to deal with condensation in our within the materials that compose our roof assemblies. And in order to do that, there's two main approaches to this. The first approach is to insulate on top of the triangle, on top of our roof deck. And this is it solves our condensation issue by making our surface warm again. So in order to have condensation, you have to have a cold surface. Well, this gets rid of the cold surface. So now no part of the triangle is cold. I mean, I guess it's cold on the outside, but we don't care about the outside. We care about the inside. So we don't have warm, moisture-laden interior air that reaches a cold surface. So that's one approach to dealing with condensation, is to insulate on the outside. The alternative approach is to insulate on the inside of our attic, but to use a special kind of insulation that is not permeable to air or water vapor. And typically what people use in this case is spray foam insulation. And specifically, they'll use closed cell spray foam insulation. We won't get into why, but they'll use spray foam insulation to basically make it so that the warm, moisture-laden interior air can't reach the cold surfaces in the roof assembly above. The downside, there's a few downsides, but the biggest downsides with both of those approaches, the first one is cost, and there's cost in a bunch of different respects. One, the surface area is bigger, so you're just buying more material to insulate on the triangle instead of on the flat. The second is that the type of insulation you use is now different. If you insulate on the top, you have to use an insulation that is appropriate to being outside. And it has to be more rigid. You can't use the less expensive loose fill insulations. And if you insulate on the inside, now you're having to use spray foam insulation, and that takes a special trade to install. And a lot of people wish to avoid using foams in their homes. So it's more expensive materially. It's bringing a different trade onto the job that's not doing any other work. I didn't mention this a minute ago, but if you insulate on the exterior, good luck finding a roofer in California.
That's not common. Not common here. Exhalation is not really not really talked about in SoCal. But why? So if we insulate on the inside, on the pitch, right? Why? I'm asking as a layman. Why can't we just use the typical, batt insulation we see? Why do we have to use the closed cell spray foam?
Because the batt insulations are too permeable to water vapor and to air, so that you still get that warm, moisture-laden air that wafts through them and will cause the roof decking, which is usually OSB or plywood, to rot. Now, so this is what has been the case for a long time. So we've had condition the attic or uncondition the attic, like vent the attic or condition the attic as our two kind of options. And like I can cheap and effective in the vented attic or expensive and complicated in the other one. Like, what are your clients going to pick? They're gonna. This is why venting is so popular. Now, there's other reasons. I'm not gonna get too down the rabbit hole in this. Actually, I have if someone wants to get into this, like more detail on this, I did a video for Acelab, Acelab. I did a video. It's free online. You can get into more of the technical weeds on this. But anyway, For a long time, these were our options, and that was pretty much it. And it was especially challenging in climates like California, where you might actually want to insulate on the pitch, but the cost delta was just like too much of like there wasn't a mid step, like there wasn't a halfway. There wasn't it was just like cheap or expensive. There wasn't like anything in the middle. And now we have a third option for us, which is really, really cool. And what this involves is adding what's called a diffusion port at the apex of the roof. So where the ridge vent would be, what we'll do is, instead of using wood sheathing all the way at like the whole part of the triangle, at the very top of the triangle, we cut out the sheathing at the very top. And we replace it with something that's vapor open, so something that we can have drying that like go through. So we'll put a building paper there, like Tyvek or something. So we cut out a small portion of the wood. The code will tell you how much to do now. I don't know what it is, but 6 inches on each side, and we'll wrap it with Tyvek, and we can now insulate using moisture sensitive insulations like a bat or a blown cellulose with netting or something. And we can permit drying to happen just at the apex without venting the whole roof. This is unbelievably helpful without the added cost. So I guess you have a moderate cost increase in that the surface area is a little bigger to do the triangle instead of the flat. But
nominal though.
No, it's nominal. Like, you've already got somebody at the job. This is not like this. You wouldn't even notice this in a bid, or you shouldn't really. This is not an expensive change, and now we don't have to vent the roof. And the story of how we know that this works is really kind of cool. And I think it's something special about our industry and the way that we practice in North America. And the way we knew about this, and stories of how big things come to pass are complicated. And I don't know all of it, but I don't know all of the history. I'm sure there's more to it than this, but these are the broad strokes. Is that on the forensic side, we noticed when we failed to vent roofs, like when people didn't do this properly, when they insulated on the underside using moisture permeable insulation and the roof started to rot, it would rot. It always rotted at the ridge. So we do this thing, we vent roofs to control moisture, to flush out moisture, to protect the roof decking. But the roof decking, when we did it wrong, when we didn't vent it right, it wouldn't rot everywhere. It rotted only at the ridge, which got people thinking, why is it only rotting at the ridge? Like, what if we added a vent, like what's called a diffusion vent? So it's not for air, it's for molecular diffusion. So this is a little bit of a harder way of thinking about things, but the simplified way is, if you have something wet and you put it next to something, or if you have something dry and you put it next to something wet, the dry thing gets wet and the wet thing gets drier. So this is what's happening is an airflow. It's molecular diffusion. So individual molecules of water move from something wet to something more dry. And by removing the moisture sensitive wood from the ridge of the roof, and replacing it with something that's vapor permeable that allows the molecules of water to escape, we can vent the roof or remove enough moisture to where we don't lose the roof. We don't have a problem with it. And if you're having trouble picturing this, by the way, you take out the roof decking, but you do have to cover it with a traditional roof vent, right? Obviously, you can't just have
a piece of Tyvek floating up the top.
Then you're back to be an LAX issue.
You do it's a little cap, almost like a chimney cap, right? You don't cap the chimney so that the smoke can't get out, but you cap the chimney to stop the rain from coming in, like an umbrella.
Right.
But anyway, we can do this, and we can do this in the best climate for this. We can't do this in every climate, right? You can't do this in Boston and have it work. It's too cold for too long. So that small amount of moisture removal isn't sufficient for climates that are really cold. So we have a lot of moisture on the inside and a lot of cold surfaces for like seasonally much longer. And it's just, we don't get enough drying. This method doesn't give us enough drying to be effective in cold climates. But you know what climate it works great in? California. It works fantastic in California. And this idea originated, I think, like 15 or 20 years ago, but we had to test it. So we had to figure this out.
20 years ago. Wow.
That's crazy.
Yeah.
So does the building code allows that to happen already? And
it
people
does,
have just not been using it?
Just allowed it to happen. Only just. Like, this is real recent. And, but so we knew that we had the idea 15 years ago, but we didn't know, like, we didn't have experience with it, right? This is just an idea. Like, how do you test it? You have to figure it out. Like, in what climates, how do we know what climates it's going to work in and what climates it won't work in? And there's a really cool story. Your listeners probably, maybe they know this, maybe they don't, but I think there's a lot of confusion among lay people about where building codes come from. And they don't realize the extraordinary feat that our code system is in North America. I mean, I know there's lots of problems with codes as well, but I'm really impressed with it generally, in that this is an almost entirely volunteer operation. So you have subject matter experts who sit on these code committees as volunteers. They are not paid. I think obviously they've got to have some paid staff somewhere, but the people that sit on these code committees are typically volunteers, and anyone can propose a code change. Anyone. Like, you don't have to be an architect. You could be an architect though. You could be a student. Anybody can propose a code change. So you propose a code change, make your case to the committee that oversees that portion of the code, and then they vote on it. And that's how we get our codes. Oh, and then individual jurisdictions will decide whether they want to adopt that code or change it or enhance it or whatever. But this is a pretty volunteer grassroots option. And I think we owe a really big debt of gratitude to a lot of professionals that don't get paid for this work, but do it to better our industry.
Fascinating.
I find it really impressive. But anyway, so this idea started like 15 years ago, 20 years ago, something like that. And my father was really interested in this. His name is Joe Stiebrick, and he's a building scientist. And he ended up getting, I think, some Department of Energy grants to figure this out as well. So they did, there were sort of two ways of testing this out that I'm aware of. They might have done, I'm sure they did more, but there were two projects that I was aware of. One was they built a test facility in my backyard, my childhood backyard. They built a test house.
Awesome.
They insulated it using different kinds of insulations, using different kinds of, so it looks like kind of a barn almost. And they did the roof. They had different bays of each bay. Rafter bay in the roof was insulated differently with a different membrane on the underside, a different and they played around with the size of the opening at the ridge, and then they simulated different interior conditions and had sensors, data loggers on the roof sheathing monitoring this, and they ran the experiment for like a year or 2 years more. I think they still have it. It's still there. So they looked at it and figured out what's going on there. So that was one experiment, and that was led by a guy by the name of Kota Ueno at Building Science Corporation with Department of Energy money. And then the other thing that ended up happening was they got a bunch of production home builders to volunteer to design roofs this way at different divisions of their company in different parts of the country.
Wow.
To test it. And they monitored the roofs, and we had to test it. Then when we had this data and this information from testing, my father, like personally, went to the code hearings. He's one guy. He like bought a plane ticket, they have him in Las Vegas a lot, and he said, "This is like we should do this." And then they said, "Okay." I mean, it took a few code iterations, I think, to get it in the code, but it is now code, and that is how that happened. Because
so cool.
like my dad noticed that the damage was only at the ridge and said, "What if we could do this differently? What if we could save some money?"
That's really, really cool. I feel like the section of code should not be an article number. I feel like it should be his name.
That's funny. I'll tell him. He'll be very flattered.
I think that would make the building code a lot more fun, to be honest, also, if it was based on names.
Yeah.
That is really, really, really cool because, one of the challenges with houses, generally speaking, but also maybe not so with the fire. The fire has just destroyed everything. But with houses is, folks want to do new construction, but that's a different thing from retrofitting or updating a house and doing a remodel of sorts. And remodels are incredibly challenging for many, many reasons. And one of them, though, is how do we do meaningful interventions that have a big impact without like destroying half the house? And it's just really hard. Like, I don't know how many houses we come across with, clients or prospective clients, and the houses from like the 1950s or the 60s. And, they start talking about their ideas and we're like, I don't even like almost nothing in this house. Like new glazing, new insulation, new everything. And it's really hard to find, again, meaningful ways to have huge impact. But on the subject specifically of how do we deal with these roofs for fire prevention or also maybe just general energy performance, this is an amazing solution.
Yeah. Yes, you make an excellent point. This can be done as a retrofit. So when you go to re-roof, you can do this.
Yeah.
And it's not, I mean, maybe it's marginally more expensive. And it'll be at first, right, as people learn how to do a new thing, because there's sort of path dependency, right? We want to do the thing that we're used to doing. But this is not this is not a big leap.
Not complicated.
This is a tiny change, yes.
Yeah.
And it's a small change that way disproportionately reduces your risk in a wildfire. It's just absolutely disproportionate.
Are there in general other benefits to have a closed roof or a non-vented roof system versus one that has an attic and has vents?
Oh, yes, there's tons of them. I really think that unless you're designing a very, very simple house, you shouldn't be venting your roof. We should be conditioning our attics now. Our houses are just even relatively simple houses are just more complex right now. So roof venting, for it to be effective, you have to have a relatively simple roof line and a clear pathway from soffit to ridge. So the way I've described it, like the triangle on top of the square, like if your house looks like that, like that's
sure. Yeah.
But increasingly we don't do that, right? And we want the freedom to do other things. So venting is not a great choice for more complicated roof lines. We also have a tendency to put our mechanical equipment in our attics, especially in warmer climates, and that can cause huge problems for us from a comfort and indoor air quality perspective inside our homes. So like beyond just risk of condensation on the ductwork and on our mechanical systems, which is a real thing, we also, by having our mechanical systems in our attics, we often will, like if we have leaky ducts, we end up, how do I describe this easiest? So when you have your air conditioner in your attic, it's a closed system. Or actually, when you have it anywhere, your air conditioner is a closed system. It's this box with ducts attached to it, and it takes warm air from the house, makes it colder, and then puts it back into the house. So like takes warm air, cools it, puts it back in, takes warm air, cools it, puts it back in. It's this circle. And if our mechanical system is in the attic, our ducts and our air handler in the attic, which they typically are in a lot of houses in mild or warm climates, and the ducts leak, what ends up happening is we take out the same amount of air from the house and it goes into the magic box to make it cool, but we don't put all of that air back in because we lose some of it to the attic. So if we take out more than we're putting back, like if you do this to your bank account, if you take out more than you put back, you create a negative pressure in the house. And then what that does is more air will have to come in from the outside from somewhere, through defects in your enclosure, through other defects in the square part of the house, the square versus the triangle, to make up for the losses in the attic. And when you do that, the air brings other things with it, like dust, like smoke, like moisture. So if you do this and you're, say, in Miami, now you have humidity problems, and you can have like serious problems with mold, with all kinds of other stuff. There's some other reasons too, but those are the highlights. It ends up being typically a lot better to condition our attics. It allows us to control our interior environment a lot better. And I don't mean control like sometimes when people hear that, they're like, especially I'm thinking of you in California, like, I don't need to control things, man. I'm cool.
That sounds like me.
It means that you can actually, like, you can have a healthier environment. Like you're not, you can bring in fresh filtered air from a location that you know about, rather than allowing air to come in from who the heck knows where. Being filtered
that's a really good
whatever
point.
the heck is in your walls and has been there for 50 years,
Yeah. That's a really, really good point. And actually I was going to mention that because we do hear from folks, and a lot of the folks we work with are in California, that when they hear about a closed roof or a closed envelope, like a fully sealed house, they think like, well, what about fresh air? Well, don't I want fresh air coming in? And it's like, well, define fresh. If you actually want fresh air, then we can do that through systems now, because we have these systems, as opposed to letting leaky air come through, which, like to your point, carries a bunch of stuff, especially in Los Angeles.
Yeah, and bringing it in through a dedicated place to bring it in under their control means that they can bring in more fresh air when they're having a party, or if they've done something in their house that they want to like flush stuff out more, like they sanded their floors, or they cleaned something. I don't know. They can adapt it, and then they can filter the air that they've brought in, so that they can have better control over their allergies. Or like if there's wildfires but not immediately threatening their home, it does affect the air quality, and you need to be able to breathe healthfully, even if there's fires in Canada. We had that problem. I don't remember what summer it was, because I've been in the mom fog for a while. But that was a big deal. Like real far away from the fires, people were still smelling it. And if you design a home to have better control over your interior environment, you can really be like orders of magnitude more comfortable in your space. That's not that expensive. Like, yes, it's expensive. You have to find a competent architect and mechanical systems designer, and you have to buy the equipment. But if you're going to the trouble to build a new house anyway, as a percentage of the total cost of your build, that's not crazy. And also, I think clients typically, they kind of care about the air they breathe, usually. Yes.
I think more and more these days, the idea of health and wellness is definitely more central in kind of the mainstream sense. I wanted to go back to an earlier point you brought up about the materials being used, and this idea that we can't use wood at all in buildings if they want to be, fire resilient. And also that reminded me, you mentioned Acelab, and Acelab, we're working with them on a few things. They've been fantastic in helping us, and as a material database. I don't know if a lot of architects know about them. If not, they should. Folks listening, you should look them up. It's like the challenge. This is a tangent now, but the challenges as an architect sometimes, especially as a small practice, is finding the right resources, the right materials, the right people, and they just make that whole process easier by hooking you up with references of like products and things, and they give you information about the products too. It's really kind of, it feels like a cheat code, to be honest, is what it feels like.
There's so many things that are sort of newer that make me genuinely wonder, like, they're so good that I'm like, how did we do this before? You know? I mean, I'm not stupid, obviously. I know how we did this before, but like what we were talking about before, the less information you have, the more conservative you have to be. The more information you have, the more creative you can be with, and that goes for materials too. If you don't know a whole lot, then you can't be more experimental about materials.
No, 100%. That's exactly it. Like sometimes, we're working on something and it's like, I think there's something out there that might solve this problem that we're dealing with. And, sometimes they're a big help to help us find it. But on the subject of materials, were you thinking mainly the materials of the structure itself, or also the exterior cladding of the house?
For the wood?
For the wood.
Yeah, I mean, yes. So in fairness, yes, if you like, flammable materials are flammable materials by definition. But there are things that we can do to treat materials to make them not ignite the same way.
Right.
Exactly.
Right.
And to be honest, I'm not a real expert on those, like parsing those differences. But I don't think that's actually that hard to kind of look up when you've got a system, and manufacturers that'll sell you a cladding system, they can competently speak to how long it takes the stuff to ignite. But with wood too, like there's things that we treat things for fire all the time. So, and I think it's also a question of what are we actually trying to accomplish? Like if the fire is like engulfing, or is right there, like the priority really does need to be to escape safely. But if it's like controlling the spread, I don't even have the vocabulary to describe this, but I think you kind of know what I mean by this.
No, it's a really good point, because we were sort of talking about this. It was on the show or maybe off the show. I don't recall, but the goal of what we're trying to achieve does need to be thought about, because a lot of the code and a lot of what we do is not necessarily to make sure the house is resilient to everything forever. It's mostly a safety thing so you can get out. And actually, this reminds me, we had a structural engineer on the show years ago now, and we were asking him about structural integrity and resiliency for earthquakes, right? Sort of parallel. And he's like, look, I could design you a house that's going to withstand anything as long as there's land underneath it, but that's unrealistic from a cost and budget standpoint, and unrealistic for our goal. The goal is to give you time to get out, or whatever it was in that conversation.
Or
it's not
when
to
it
construct
fails, it fails in a way that's designed to minimize loss of life.
Yep. That's exactly it. As opposed to trying to create a structure that's going to be the only thing standing, if the entire city goes away.
Yes,
and I think the same.
I mean, it is true. If we built with only non-flammable materials, yes, that, like, if you're comparing a house built with wood frame materials or with a wood frame versus a concrete or steel frame, yes, like, stuff that burns, stuff that doesn't burn. But that's not those aren't the only factors.
And I think the bigger underlying question is, like you mentioned tornadoes. It's like, if you are going to build in a zone that is at risk, you are taking a risk.
Sure.
And it poses the question: should we be building in those zones of earthquakes and tornadoes and wildfires? Floods, like
all kinds of stuff these days.
We are in some ways already looking for some trouble. Like,
we had an architect colleague say that to a bunch of architects, and then the room went kind of silent.
No, but it's a valid question. It's a very valid question. But I think it's kind of going on a tangent. But I think it's hard for like the human species to kind of realize that we probably shouldn't do that. Let's move on and do something that makes more sense, because
there's a lot of factors
because we tend
at
to
play.
forget,
That's I think that's true. But what I was trying to get at too is that I think for the layperson, sometimes they hear or see fires, right? And they think about houses, and they see wood stick framing type 5. They don't know the type 5, but type 5 framing.
Right.
And they're like, well, 1 and 1 is 2. What are we doing?
That's my dad right there. He's always asking,
exactly.
why would you be building with wood where it burns? And I'm like, I understand.
and I get it. I get it to a degree. But at the same time, you have layers outside of the studs which provide all this protection. So it's not stupid. Like, people think it sounds stupid on paper. I get it, but it's not, because we have all the stuff on the outside, which is being used as a shield to protect the studs anyway. Like, if the fire gets to your studs,
stuff on the inside. I mean, we have like furniture too, but we do fire protection on the inside too. We think about this more on commercial buildings, but we have fire rated walls and separations, and we protect certain structural elements more than others. Like, we protect structural elements more than non-structural elements.
Yeah.
It's a pretty sophisticated approach. And I think what it is that there are some people that object to the concept of trade-offs existing, like, ever in any context. Maybe not any context, but they feel entitled to the lowest cost, safest option at all times. And like, as sort of a matter of principle. And I think it's just not a very serious way of thinking about almost anything. Like, trade-offs exist, we make them, and it's hard to make them. And I think it requires a lot of experience and sensitivity, and we should acknowledge that. And we don't always know what the right thing to do is, but if you don't acknowledge the trade-off, you still end up making the trade-off, but somebody else makes it for you, really. And I remember this was before I was married to my husband. We went to this party. I think it was actually even before we were engaged. We went to this sort of informal party, and we met this guy there, and he asked what I did. And I told him about at the time I was doing a lot more, most of my practice was forensics. But I was helping a little bit with, actually, this is what it was. I had just started doing a lot more new construction work. And I gave him the example, like, it was a water management example. I said, suppose you're a developer and you install 10,000 windows a year. You know how many of your windows fail from leaking, that you have to go back and then repair later. And there's a cost associated with that. You have to relocate tenants. You have to repair whatever was damaged and replace the window. And, there's a cost associated with that, and you know what it is, because you pay it, every year you pay it. Someone like me, there's a lot of different types of windows you can buy, and there's different ways of installing them. So somebody like me can take a look at what you're doing right now and tell you from a technical perspective what things you could do, maybe a different product you could buy, or how you could alter your installation methods to reduce whatever that percentage of failure you have, from, say, like a 1% failure rate to 0.5% or 1/4% or 0.1%. And you get to decide whether you do that or not, whether that's worth it. Because at a certain point, it's cheaper to just go and fix the unusual problem that you've had than it is to make a change for 10,000 windows. Anyway, I was talking to this guy, explaining it in this way, and he got so angry and was like, well, my tolerance for failure is 0. And I was like, I don't know what to tell you, but I can guarantee you that 100% of the windows on your house leak. And he was like, what? No, they don't leak. And I was like, have you looked at your walls? And even the manufacturers don't promise you that those windows won't leak. Yeah. What they tell you is, we have tested these windows in a laboratory under these very specific conditions. And under these conditions, this window doesn't leak. That's what they've told you. And that's in a lab. So are your lab conditions what your house is experiencing 50 years after it's been built, 100 years after? Maybe not. My bet is on not. But anyway, I remember it at the time because my husband was just sitting back, like, watching this. And
this guy gets so angry about his windows.
And the one who it was at our friend's house, a friend of his from high school. And the friend was like, are you going to do anything here? And my now husband, but then I guess boyfriend, was like, no, this is real interesting. Because he was really, the guy I was talking to was very upset about this. And
that's so funny. Was he a contractor?
No, he wasn't a contractor. He was just a guy. He was saying he was really angry at the concept of trade-offs, at the concept of having to like not be able to sort of have to. I don't know what it was. I guess an unwillingness to think intelligently that there's trade-offs, like that. Yeah. How much do you want to live in a submarine? Like we can do that. Yeah. Like we can make pretty good windows, like little portholes or whatever. But at a certain point, that's not really the cost benefit analysis doesn't work out for most people. But that's the beauty, though, and a beauty of what we do in architecture is that we get to assess what people's resources are and what their preferences are, and help them make the best use of the resources they have so that it kind of meets their tolerance for risk and their expectations for performance. And the more we know about some of the science part of it, the better that we can assist them. And for some clients, like maybe the answer is for somebody like this. I mean, this would be, I'm not taking this job, but for some people, it's, you're very risk averse. Like, I don't think this is a good place for you to build. Like, maybe that ends up being something that we say, we can elevate your house, or if it's in a flood zone or something, these are the things that we can do. But have you considered maybe a mountain home instead or whatever?
I love that point. It's a really, really good one. I agree entirely. It's kind of what architects do. And it's the challenge of, I think, being an architect, and the fun of it is you're always thinking about these trade-offs and throwing into the mix, the cost, performance, the design, the schedule, client preferences, like all of these things are always being juggled constantly. Yeah. And I think the good clients are the ones who know themselves and are able to trust the people they hired is to advise them of like the options, like you mentioned, and then choose the right path, that makes sense for them. But there are definitely, that's how it works. And there's almost too many variables for any client to fully understand all the variables all the time in a project.
That's why I tell them to hire an architect. They don't have to hire an architect. This is
correct.
I mean, this is why I tell people to hire an architect. It's because you don't know what you don't know, and you can have somebody who knows this stuff better, who can be your advocate, and who can help you make the very best use of your resources, and help you say, like, you know what, this other thing, maybe it is a little bit more expensive and it's worth our house being a little bit smaller for, or this other thing, not important at all to you. Like, okay, we don't have to do that. And having somebody who really knows this stuff will get you more of what you want. And I think the people who have this idea that they have to negotiate against the professionals that they hire miss out on like kind of the most important thing that their architect and also their contractor, if their contractor is good, can do for them, which is to get them more of what they want for less, right? Yeah.
Another really good point. That is a great place to end it as well. It is, on people listening, this is a Friday evening, on the East Coast, so this is like extra gold points to you for being so dedicated. Thanks so much for making the time on a Friday evening to chat with us. I think there's so much more to talk about for sure. So let's do this again, hopefully sooner than later. And this was amazing. The time flew by. I knew it was going to fly by. We could keep talking for the next 6 hours, but it's like dinner time for us and probably getting close to bedtime for you. So we can.
It's 9:03. It's 3 minutes past my bedtime.
3 minutes. There we go. See, Christine, thank you so much. This was amazing.
Thank you.
Thank you.
Hi, everyone. Thanks for watching this video on YouTube. If you like what we're doing, then please support our show by hitting that subscribe button.
You can also find us on most of the social media, Facebook, Twitter, and Instagram. We're mostly on Instagram. And you can reach out to the hotline, 213-222-6950. You can send a text message or leave a voicemail if you have any reaction to this recording, any questions you might have, or guest suggestion. Feel free to send it our way.
Cool. Thank you for watching, and see you next week.
Thanks.
Bye.
Bye-bye.